Welcome to our deep dive, into the world of Galilei.
Hmm.
We'll be exploring excerpts from the Stanford Encyclopedia of Philosophy's entry on Galileo.
Okay.
And trust me, there's so much more to him than just, telescopes and squabbles with the church.
Right.
We're going to uncover how Galileo, the philosopher, revolutionized our understanding of the cosmos and laid the groundwork for a whole new way of doing science.
What's fascinating is that Galileo wasn't content with just observing the universe.
Yeah.
He wanted to explain it to unveil the mathematical language that he believed underpinned all of physical reality.
Hmm.
This was a radical departure from the Aristotelian natural philosophy that had dominated Western thought for centuries.
So it wasn't enough to just describe what he saw?
Yeah,
He wanted to explain the why behind it all.
absolutely.
This is a huge shift, right?
Absolutely. And to really grasp the magnitude of this shift, we need to step back and look at the Aristotelian worldview that Galileo was challenging.
Okay.
Imagine a universe where everything has its proper place. The Earth at the center, surrounded by celestial spheres, each composed of a unique element with its own set of rules.
Okay. I'm picturing a very ordered hierarchical cosmos.
Precisely. And in this system, knowledge about the natural world was primarily derived from observation and logical deduction based on pre-existing assumptions about the nature of reality.
Hmm.
Galileo was proposing something radically different, a universe governed by universal mathematical laws, discoverable through a combination of observation, experimentation, and mathematical reasoning.
So in essence, Galileo was arguing for a more active, investigative approach to understanding the universe rather than just passively accepting traditional wisdom.
Exactly. And one of the key elements of this new approach was his concept of a unified theory of matter.
Okay.
Galileo rejected Aristotle's idea of distinct celestial and terrestrial elements, arguing instead that all matter in the universe, whether on Earth or in the heavens, is fundamentally the same.
Okay.
This was a revolutionary idea that would have profound implications for how we understand the cosmos.
Okay, so he's basically saying there's no magical ether up in the heavens. It's all just matter.
Yes. And this idea of a unified matter theory wasn't just a philosophical musing. It had practical implications for Galileo's scientific investigations.
Right.
His early work, particularly his unpublished treatise De Motu, reveals him grappling with this concept as he attempts to explain motion using a single principle, heaviness.
Now, this is where it gets interesting for a philosopher like myself.
Right.
He's trying to strip away the complexity and get to the core of how things move,
Yeah,
using something as seemingly simple as heaviness.
right. And while his early attempts in De Motu might seem rudimentary compared to his later breakthroughs,
Yeah.
they highlight his relentless pursuit of a unified, mathematically grounded explanation for natural phenomena.
Yeah.
He was laying the groundwork for his later, more refined theories of motion.
So it wasn't a straight path to scientific revolution.
Yeah.
He had to wrestle with these foundational concepts before arriving at his groundbreaking insights. It makes you wonder, what was it about Galileo's approach that allowed him to break free from these traditional modes of thinking?
Well, I think one key factor was his willingness to challenge deeply ingrained assumptions.
Okay.
In De Motu, we see him questioning the very notion of heaviness as the sole principle of motion.
Right.
He uses thought experiments and analogies like the balance and the lever to explore the relationship between weight and movement.
So these everyday objects, balances, and levers, they become tools for him to dissect and analyze the fundamental principles of physics.
Exactly.
That's pretty clever, using the familiar to understand the complex.
Exactly. And by applying mathematical principles to these simple tools, he begins to chip away at the Aristotelian framework and develop a new language for describing the physical world.
It's like he's taking philosophy out of the abstract realm
Mhm.
and grounding it in the tangible world of experimentation and mathematical analysis.
Precisely. And this approach would eventually lead him to his groundbreaking law of free fall, which completely overturned centuries of Aristotelian thought about how objects move.
That's the one where he supposedly dropped objects from the Leaning Tower of Pisa, right?
Well, the Leaning Tower story is likely apocryphal,
Oh, okay.
but it captures the essence of Galileo's challenge to the established order.
Right.
He demonstrated through meticulous experimentation and mathematical reasoning that all objects, regardless of their weight, fall at the same rate in a vacuum.
Right.
This contradicted the Aristotelian belief that heavier objects fall faster.
It's a simple concept, but it's so profound when you think about it.
Yeah.
It's like he's revealing a fundamental truth about the universe that had been hidden in plain sight for centuries.
And this discovery was just the beginning of his remarkable journey.
Okay.
Galileo's observations with the telescope would further solidify his break from the Aristotelian worldview and pave the way for a truly revolutionary understanding of the cosmos.
So from challenging the very nature of matter to rethinking how objects move, it seems like Galileo was constantly pushing the boundaries of knowledge.
Yeah.
I'm eager to delve deeper into his astronomical observations and see how those further fueled his philosophical revolution.
Okay.
Let's do that after a quick break.
Sounds good. And it's with the telescope that Galileo really throws down the gauntlet, challenging not just scientific theories, but the very foundation of the Aristotelian worldview.
So he's pointing this newfangled instrument at the heavens and seeing things that no one had ever seen before. What kind of impact did these observations have on philosophical thought at the time?
Well, imagine the philosophical earthquake when Galileo publishes his observations of mountains on the moon and spots on the sun.
Hmm?
These were supposed to be perfect celestial bodies, not blemished, imperfect things like the Earth.
It's like he's puncturing the idea of these two separate realms, the celestial and terrestrial, blurring the lines between them.
Precisely, and it gets even more profound when he discovers the moons orbiting Jupiter.
Okay.
Here you have celestial bodies not orbiting the Earth, but another planet.
Wow.
This directly contradicted the geocentric model that placed the Earth at the center of everything.
So he's providing concrete, observable evidence against the prevailing philosophical and scientific dogma of his time.
Yeah,
That must have been a real mind-bender for people back then.
absolutely. And keep in mind, this isn't just about overturning a scientific model. It's about redefining humanity's place in the cosmos.
Hmm.
If the Earth isn't the center of the universe, then what does that mean for our understanding of ourselves and our relationship to the divine?
It's like he's forcing people to confront a whole new reality, one that is far more complex and nuanced than the neat and tidy Aristotelian system.
Exactly. And Galileo doesn't stop there.
Okay.
He uses his observations of the phases of Venus to further dismantle the geocentric model.
Mm.
These phases, similar to the phases of the moon, could only be explained if Venus was orbiting the sun, not the Earth.
So with each new observation, he's chipping away at the philosophical foundations of the Aristotelian worldview, building a stronger case for a heliocentric system.
And it's not just the observations themselves. It's his interpretation of them, his insistence on using mathematical reasoning to explain what he's seeing.
Right.
This is where Galileo's philosophical commitment to a universe governed by universal mathematical laws really comes to the forefront.
Right. It wasn't enough for him to just say, hey, look what I found.
Yeah.
He wanted to explain why these observations mattered,
Yeah.
how they fit into a larger framework of understanding the cosmos.
And this commitment to mathematical explanation led him to introduce groundbreaking concepts like circular inertia and the relativity of motion in his dialogue concerning the two chief world systems.
Now, those sound like some pretty heady concepts.
Yeah.
Can you break those down for us in terms that even a non-philosopher could understand?
Of course, circular inertia, as Galileo understood it, is the tendency of an object to continue moving in a circle unless acted upon by an external force.
Okay.
This concept was crucial for explaining how objects could remain on a rotating Earth without being flung off into space.
So it's like how a ball on a string will keep spinning in a circle as long as you keep swinging it.
Right.
It's that inherent tendency to stay in motion along a curved path.
Precisely. And the principle of relativity of motion states that the laws of physics are the same for all observers in uniform motion.
Okay.
In other words, if you're on a smoothly moving ship, you can't tell whether you're moving or standing still just by observing the behavior of objects around you.
Okay. I think I'm starting to get it.
Yeah.
So if we're on a moving Earth, we wouldn't necessarily feel that motion because everything around us is moving at the same speed.
Right.
It's all relative.
Exactly. These concepts were revolutionary because they provided a framework for understanding motion on a moving Earth, effectively countering arguments against the Copernican theory.
So he's not just dismantling the old worldview. He's offering a compelling alternative one that is grounded in observation, experimentation, and mathematical reasoning.
And he doesn't shy away from trying to prove his point.
Right.
One famous example is his attempt to explain the tides as a consequence of the Earth's motion.
Right. I remember reading about that.
Yeah.
He thought the tides were caused by the combination of the Earth's rotation and its orbit around the sun.
Exactly. He believed that the water in the oceans would slosh back and forth as the Earth moved, creating the tides. While his theory was ultimately incorrect, It highlights his commitment to finding mechanical explanations for natural phenomena, even the most complex ones.
It shows that he wasn't afraid to push his ideas even if they weren't always perfect.
Right.
He was willing to put his theories out there and let them be tested, refined, and sometimes even debunked.
And this relentless pursuit of a unified mechanical understanding of the universe is what ultimately led him to his final masterpiece, The Two New Sciences.
Hmm.
This book is the culmination of his life's work, where he tackles the very nature of matter and motion, laying the groundwork for modern physics.
It's amazing to think that one person could have such a profound impact on our understanding of the world,
Yeah.
from challenging centuries-old philosophical dogma to revolutionizing the way we study the cosmos. Galileo's legacy continues to shape our intellectual landscape today.
Indeed. And as we delve into the two new sciences in the next part of our deep dive, we'll see how Galileo's insights into the nature of matter and motion laid the foundation for a truly modern scientific worldview, one that continues to influence how we understand the universe and our place within it.
So we've been tracing Galileo's journey from challenging the very foundation of Aristotelian physics to revolutionizing astronomy with his, groundbreaking observations.
Right.
And now we arrive at his final masterpiece, The Two New Sciences, a work that really solidifies his place as a pioneer of modern science.
What's remarkable about the two new sciences is that Galileo takes all the threads he's been developing, his ideas about matter, motion, mathematics, and weaves them into a coherent, groundbreaking exploration of the physical world. This isn't just a collection of observations or philosophical musings. It's a systematic investigation into the fundamental principles that govern the universe.
So it's like he's presenting a new blueprint for understanding reality itself, a blueprint built on the foundations of mathematics and experimentation.
Exactly. And one of the key areas he tackles in this book is the nature of matter.
Okay.
Galileo was fascinated by the question of what matter is actually made of, and he rejected the prevailing Aristotelian view of four elements, earth, air, fire, and water.
Right.
Instead, he envisioned matter as being composed of infinitely many indivisible points.
Okay, so hold on. He's saying that matter isn't made up of these fundamental building blocks like atoms, but rather these abstract mathematical points. How does that even work?
It's a very intriguing concept, and it shows how deeply Galileo was thinking about the relationship between the physical world and the realm of mathematics.
Okay.
For him, these indivisible points were mathematical entities that, when combined in different ways, could give rise to the different properties of matter that we observe.
It's like he's trying to bridge the gap between the abstract world of mathematical concepts
Yeah.
and the tangible reality of our physical experience.
Right.
Exactly. And this approach allows him to tackle questions about density, strength, and the nature of motion in a whole new way.
Okay.
He uses thought experiments, geometrical demonstrations, and mathematical reasoning to analyze the behavior of matter under different conditions.
So he's not just relying on observation.
Yeah.
He's using the power of mathematics to probe the very essence of what makes up the physical world.
Precisely. And this leads him to some groundbreaking insights about motion.
Okay.
In The Two New Sciences, he delves deeper into the concept of acceleration, which we touched on earlier.
Right. That's the idea that objects don't just move at a constant speed.
Yeah.
They can speed up or slow down over time.
Exactly. And Galileo meticulously dissects this concept using inclined planes and pendulums to carefully measure and analyze how objects accelerate under the influence of gravity. He demonstrates the mathematical relationships between distance, time, velocity, and acceleration, laying the foundation for what we now call classical mechanics.
It's amazing how he was able to develop such sophisticated concepts without the benefit of the mathematical tools that we have today, like calculus.
It's a testament to his ingenuity and his deep understanding of the physical world.
Yeah.
He was able to visualize and analyze complex physical processes using a combination of geometry, algebra, and careful observation.
And it wasn't just about describing motion. It was about understanding the fundamental principles that govern it.
Yeah.
He was searching for the underlying laws that dictated how objects behave in the universe.
And one of the key principles he explored was inertia.
Oh.
He recognized that an object in motion will continue in motion at a constant speed and in a straight line unless acted upon by an external force.
Right.
This idea would later be formalized as Newton's first law of motion, but Galileo laid the conceptual groundwork for it.
So he's chipping away at the Aristotelian notion that objects have an inherent tendency to come to rest.
Exactly.
Instead, he's proposing that motion is the natural state of things unless something acts to change it.
Exactly. It's a profound shift in thinking about the nature of motion and a key step in the development of modern physics.
It's remarkable to see how, throughout his life, Galileo challenged prevailing philosophical and scientific dogma, paving the way for a new understanding of the universe based on mathematics experimentation and the search for universal laws.
And his impact extends far beyond his specific discoveries.
Mm.
He inspired generations of scientists and philosophers to approach the world with a critical eye, questioning assumptions and seeking deeper explanations for the phenomena we observe.
So as we wrap up our deep dive into the world of Galileo, what are some of the key takeaways for a philosopher listening to this? What can we learn from his approach to knowledge and his relentless pursuit of a unified understanding of the cosmos?
I think one of the most important lessons from Galileo is the power of questioning received wisdom.
Hmm.
He wasn't afraid to challenge centuries-old beliefs, and he showed that even seemingly unshakable dogmas can be overturned through careful observation, rigorous experimentation, and a willingness to embrace new ideas.
He also highlights the importance of combining different modes of inquiry.
Right.
Galileo was a master of blending philosophical reflection, mathematical reasoning, and hands-on experimentation.
Yeah.
He showed that true understanding requires a multifaceted approach where different perspectives can inform and enrich each other.
And finally, I think Galileo reminds us that the pursuit of knowledge is an ongoing journey.
Hmm.
He was constantly revising his ideas, refining his theories, and pushing the boundaries of what was known. He embodied a spirit of intellectual curiosity and a deep commitment to unraveling the mysteries of the universe.
So in a sense, Galileo's legacy is not just about the specific discoveries he made, but about the spirit of inquiry. He embodied a spirit that continues to drive scientific and philosophical exploration to this day.
Precisely. And as we look out at the vastness of the cosmos, with all its mysteries and wonders yet to be uncovered, we can draw inspiration from Galileo's bold attempt to read the book of nature and unveil the mathematical language that he believed lay at its heart.
He set a high bar for all of us who seek to understand the universe and our place within it. Thanks for joining us on this deep dive into the fascinating world of Galileo. We hope you found it enlightening and perhaps even a bit inspiring. Until next time, keep exploring, keep questioning, and keep seeking a deeper understanding of the cosmos and the wonders it holds.